Now we're going to talk about the anatomical brain lobes and the physiological functional areas of the brain. So anatomically, the brain has, or the cerebrum is made of the frontal lobe, parietal lobe, occipital lobe, and temporal lobe. And these lobes anatomically are very distinct. In each one of these lobes, we have certain functional areas. We do not know exactly their exact anatomic locations, but we know that in the frontal lobe, somewhere in the most anterior part of the frontal lobe, we have the prefrontal area that is concerned with behavior. And towards the back of the frontal lobe, between just at the border of the frontal lobe, between the frontal and the parietal lobe, we have in green here, we have the primary motor area. So this is the primary motor area in green. And right in front of it in yellow, we have the premotor area. And this is what we have in the parietal lobe, the primary sensory area; in the occipital lobe, the primary visual cortex; in the temporal lobe, the primary auditory cortex. But now I want to focus on these two areas. The premotor area, which is part of the extrapyramidal system, and the primary motor area, which is the center of the pyramidal system. So let me talk about these two systems, the pyramidal and the extrapyramidal systems. So let me shift to the whiteboard now. So if I draw the two hemispheres of the brain, like if I open the two cerebral hemispheres like a book, like this, and here is the pons and medulla, the brain stem. So I'm gonna draw the primary motor area in blue, and the premotor area in red. So that's the premotor. And in blue, we have the primary motor area. Now, each area has cells. The primary motor area has the nerve cells of the pyramidal tract or pyramidal system, and the premotor area has the nerve cells of the extrapyramidal system. So, by the way, every neuron is made of a cell body like this that has the nucleus and a long axon or nerve fiber. That's the structure of any neuron. So these cell bodies are present in the premotor area and primary motor area. And when groups of nerve fibers or axons travel together in one bundle, we call this bundle tract. So when we say pyramidal tract, it's the nerve fibers coming from the primary motor area traveling in one bundle. We call it pyramidal tract. So here in the primary motor area in blue, we have the cell bodies of the pyramidal system. And in the premotor area, we have the cell bodies of the extrapyramidal system. Now, out of these cell bodies come nerve fibers. And the nerve fibers coming from the primary motor area, I'm going to draw them in blue, they follow certain tract and they cross to the opposite side. Okay, so they come out of the primary motor area and they cross to the opposite side. And this area of decussation is going to look like a pyramid, hence the name pyramidal tract. So look at this area of decussation. It looks like a pyramid. So we call these nerve fibers pyramidal tract. Where do they go to? This is the pyramidal tract. These nerve fibers go to the muscles, to the skeletal muscles. So that's a skeletal muscle. Skeletal muscle is the muscle attached to bones that you move voluntarily. So this is skeletal muscle. And this area is responsible for the voluntary movements of the skeletal muscle. So whenever I want to pick up this clicker or pick up this Apple Pencil, I move my hand. So the order starts in the primary motor area. Out of it comes nerve fibers known as pyramidal tract. They travel together in one bundle of nerve fibers, and these nerve fibers maybe will send the signal to a second neuron and a third neuron until eventually the message reaches the skeletal muscle and I move my hand voluntarily. That's the pyramidal tract. Now let's move to the premotor area. The premotor area has cells, and out of these cells come nerve fibers, and these nerve fibers do not travel in the same bundle as the pyramidal tract. They travel in outside bundles. So maybe they travel like this, they travel separately like this. So they travel outside the pyramidal system. That's why we call these fibers extrapyramidal. We call these fibers extrapyramidal because they do not follow. It's like you and your friend going to one destination, but you take different freeways. Okay, so these extrapyramidal tract these fibers, where do they go to? They also go to the skeletal muscles. They go to the skeletal muscles. What are they responsible for? The extrapyramidal fibers are responsible for the tone in the resting muscle. What is this tone? Now, when you're listening, when you're sitting down listening to this lecture right now, tell me about your muscles. Do you have zero tension in your muscles? You're resting, you're not voluntarily moving, you're just sitting and listening to the lecture. Tell me about the muscles of your trunk, the muscles of your upper limb, lower limb. Do they have zero tension? Are they completely flaccid? Of course not. Otherwise, you would have fallen off the chair. So you have some tone in this muscle. Yes, this tone is not 100%. You're not sitting like that, like a wood statue or iron statue. No, you're kind of relaxed, but you still have some residual tone. This tone in the resting muscle is the function of the extrapyramidal tract. So the extrapyramidal tract provides tone, provides muscle tone. And the pyramidal tract is responsible for voluntary movements. Okay. Now, what controls the primary motor area? Nothing. It moves, it is controlled voluntarily. So the decision starts here and nothing controls the primary motor area. Whereas the premotor area, which is the center of the extrapyramidal system, is controlled by group of nerve cells in the medulla, in the brain stem. And this group of nerve cells is known as the basal ganglia. So we have here in the medulla, we have the basal ganglia. And this basal ganglia all the time is controlling the promotor area. What do you mean controlling? It's pressing the brakes. It's pressing the brakes. So this basal ganglia it keeps the premotor area partially inhibited. It's pressing the brakes. Otherwise, if the premotor area is allowed to work full power, the tone in your muscles will increase significantly and you're going to be very rigid. When you are not moving, you are sitting like a statue. You have very high tone, very high rigidity in your muscles. Not only this, but you will start doing involuntary movements anywhere in your facial muscles with your fingers, involuntary movements. And we call these two symptoms muscle rigidity, involuntary movements. We call them extrapyramidal symptoms. Muscle rigidity and increase and involuntary movements, resting tremors, resting involuntary movements at rest. We call them extrapyramidal symptoms. So all the time, normally our premotor area is not released from inhibition. Normally, the basal ganglia is pressing the brakes kind of gently so as to keep the premotor area reasonably inhibited. So it's not completely inhibited, otherwise you wouldn't have tone in your resting muscles, and at the same time it's not allowed to do what it wants to do full power, otherwise you would have developed severe muscle rigidity and involuntary movements. But the basal ganglia, which depends on dopamine for its normal function. Dopamine is essential for the normal function of the basal ganglia. Why is dopamine essential for the functioning of basal ganglia? And we're going to talk about it later, because in the basal ganglia, we have dopamine, we have acetylcholine, and dopamine is like mom in home, and acetylcholine is like the naughty kids. So whenever mom is at home, the naughty kids behave, and mom is responsible for keeping discipline at home. But if mom is not at home and the naughty kids are left by themselves, they are gonna mess up. Same with dopamine and acetylcholine in basal ganglia. And this is an introduction to the pathophysiology of Parkinson's disease. In Parkinson's disease, mom is not at home. In Parkinson's disease, dopamine is deficient in the basal ganglia. So who is gonna take over? The naughty kids, acetylcholine. And acetylcholine will mess up with the function of the basal ganglia. And the basal ganglia will stop pressing the brakes, and the premotor area will be released from the inhibition, and the patient will develop extrapyramidal symptoms. What are the extrapyramidal symptoms? Muscle rigidity, involuntary movements that occur at rest, and these are the resting tremors characteristic of Parkinson's disease. So let me put the comparison between the pyramidal system and the extrapyramidal system in a table. I'm going to use the same colors that I used in drawing. So here I'm going to use the pyramidal in blue. And in red, I'm going to use the extrapyramidal. Okay. So the pyramidal system, it originates in the primary motor area. The extrapyramidal originates in the premotor area, which is just anterior to the primary motor area. That's the first difference. What do we call the nerve fibers that come out of the primary motor area? We call them the pyramidal tract. So the pyramidal tracts, they include the nerve fibers, and they go all the way to the skeletal muscles. What are the skeletal muscles? The muscles attached to your skeleton, the muscles attached to your bone, to your bones. So the extrapyramidal fibers, so the extrapyramidal fibers, which travel in a different freeway, in a different tract other than the pyramidal fibers, they too go to the skeletal muscles, the same muscles. So each muscle, the nerve supply of each muscle, carries orders and carries information coming from two centers. One coming from the pyramidal system, one is coming from the primary motor area, which is a voluntary message. So whenever your brain decides to move, this voluntary action is executed by the muscle that receives this order via the pyramidal tract fibers. And the other information or the other message is concerned with the muscle tone at rest, while you're not moving, you're still keeping some tone in your skeletal muscles. And this order comes all the way from the premotor area down the extrapyramidal fibers to your skeletal muscles. So the function of the pyramidal system is voluntary movements. So at rest, your pyramidal system is not at work. Your pyramidal system works only when you move. Whereas the function of the extrapyramidal system is keeping a basal level of muscle tone at rest, which means when you are moving, your extrapyramidal system stops working, and now this is the turn of the pyramidal system. But when you are at rest, the pyramidal system stops working, because now this is the time for the extrapyramidal system to provide some tone in the resting muscles. The pyramidal system is under voluntary control. What controls the pyramidal system? Your will. You want to move, you're willingly controlling your voluntary pyramidal system. But the extrapyramidal system is controlled, and controlled here means partially inhibited by the basal ganglia. Where are the basal ganglia? In the brainstem. The basal ganglia are in the medulla. Can the pyramidal system get out of control? Nope. It cannot get out of control because it is autonomous. It controls itself. But if the extrapyramidal system is out of control, if the basal ganglia stops working, you develop extrapyramidal symptoms. EPS is the abbreviation for extrapyramidal symptoms. And these extrapyramidal symptoms are muscle rigidity, which means increased muscle tone at rest, and involuntary movements. And these involuntary movements occur at rest, because when involuntary movements, this is an extrapyramidal thing, and your extrapyramidal system does not work when you are moving, because when you are moving, the pyramidal system is going to take over. The extrapyramidal system is at work only when you're not moving, when you are at rest. Okay, so this screen actually will be very helpful when we come to the discussion of Parkinson disease, and it's very helpful to have these differences clear about the pyramidal system and the extrapyramidal system, and that will be enough for this segment.